Hello and welcome everybody to SCAIME Web Conference 2021, and especially today to our presentation whose subject is Manage a Structural Monitoring Project with SCAIME Fiber Optic Technology. For those who don't know us or don't recognize us because of the mask, my name is Christophe Ourdouillet. I'm the Business Development Manager at SCAIME, and I'm sitting here together with Patrick Ray, who is the product manager for fiber optic range at SCAIME. So Patrick will be the main presenter of the slideshow, and I will be the moderator. So just to make things clear about the organization and the conduct of the session, the slideshow in itself will last more or less 14 minutes, and it will be followed by a session of questions and answers of more or less 10 minutes. The direct interventions during the slideshow are not permitted, so I advise you to use the question and answer message box, which is at the bottom of your screen, to send your questions, and we will review them at the end of the slideshow and answer them directly. So the purpose of this presentation is to shed a light on the guidelines and the recommendations to set up an efficient and well-designed structure monitoring system using FBG sensors. In the same time, we will review the theoretical principles of the FBG, the advantages versus conventional technologies, and illustrate this with application examples and SCAIME success story in structure monitoring. So I hope you will find this presentation instructive and useful. And now I'm leaving the mic to Patrick for the presentation itself.
Thank you, Christophe, for the introduction. So I'm Patrick Ray, the product manager for our fiber optics range of products here at SCAIME. And we will today present the how to manage a structural monitoring project with our technology. So we will start by a brief technology flashback or presentation for those who don't know at all, and the key benefit of this technology, our product very quickly, some typical applications so you can understand where we work and what kind of project we usually handle. Then one key point for our technology FBG is the designing of the monitoring installation, more specifically the optical lines with several sensors in series. And the quick question we have very often is how many sensors per line? So we'll give you some information on this, on how to know or to calculate. And then FBG sensor installation, more to present you the different tools we can provide to help you in this very important step. And lastly, the interrogator and the web server, the integrated web server, and we will present how to very quickly set up all the parameters of the system and of the sensors in this web server. So the Bragg Grating basically is a kind of mirror, let's say, which is graved inside the core of an optical fiber. This is done by a laser, and it measures roughly 1 centimeter long. And this mirror has the property to have a reflect only a very specific wavelength or color from the light that is sent into the fiber. And when this grating is stressed, then the wavelength we shift is what you can see on the right of the schema. So if the stress is increased, the peak, the reflection peak will go to higher wavelengths, and if it decreases, it will go in the other direction. And this shift give the information of stress, and exactly the same phenomena exists for temperature. So if you have an increase of temperature, you will have an increase of wavelengths, and measuring the variation of wavelengths, you can have the information on temperature. Then in case of for deformation measurement, then the Bragg grating is used exactly as a standard strain gauge. So we design a sensor body that will, let's say, translate the mechanical deformation. It can be acceleration, deformation, inclination. It will transform this to deformation of the Bragg grating, and we will measure this deformation, and from this we can give the mechanical value interesting for the application. So as I mentioned, the temperature, the sensor is, the Bragg grating, sorry, is sensitive both to temperature and to deformation. So we have to measure temperature close to the sensor most of the time. If the temperature can vary, in order to remove the signal which is due to temperature from the sensor. And this is done automatically in our interrogators. So to make this temperature measurement, we just have a Bragg grating, which is in a body with absolutely no mechanical solicitation can be transferred to the Bragg grating. So the grating, the sensor is sensitive only to temperature, and measuring the temperature variation, we can compensate the signal from the other sensors. So this means also that in the lines we will have to integrate some temperature sensors into, for this compensation. One important point is that, well, two important, but the one point is very important, which is the key point for our technology, is that since all grating will have one specific wavelength reflection, for example, blue here, we can have other Bragg grating after the light which is not blue, will go through the fiber, will go to the yellow one, then will be reflected, and so we can measure both, and then have many Bragg grating in series. In our systems, we are limited to 16. I will come back to this in a few slides. But this is a physical, well, we decided to limit the possibility to 16 because in the real life, we will see that usually we are more around 10, and it depends really on what we want to measure and how we want to measure. The second important point is that since the interrogator will only see some Bragg gratings, then this will be another point of the presentation. We will set up parameter to transform the wavelength variation into mechanical values, into, I don't know, accelerations or tilts or whatsoever. Then we can have any kind of sensor in series with any other kind of sensor. So we can have acceleration, strain, temperature, anything mixed on each line. So now the main benefits of this technology. So sensor in series, I mentioned it, which is very helpful to have easier cabling. If you have 10, 15 sensors in series on one cable, in the end you have only one connector to plug to the interrogator. So you have much less cables, so less problems of cabling, and of course lower cost. And the second point with this sensor in series is that the interrogator, which is what is the most costly part of the installation of the of the whole system, then is the price is divided by many sensors. If you can have up to 100 sensors on one system, so the price per measurement point, which is in the end the most important, is decreasing a lot with the number of sensors. Then other benefits, I'm sure you know them, but I just repeat them, that optical fiber is immune to electromagnetic interferences. It's only light passing through. So it's very helpful for use in environments where you have very strong electromagnetic fields, when you are antenna, radars, high voltage cables, or when there is some lightning. Second very important point is there is no risk of corrosion. It's only glass, the fiber itself. So the risk of, in marine environment, there is no risk of corrosion. And so it's another very important and convenient point for this technology. Then this is optical. The optical fiber is glass, made of glass, so it's very, very resistant to cyclic fatigue. So there is no risk of drift of the signal in time, and we can have measurement during many, many years, and also with very high deformations. Other interesting benefit is our interrogators, at least for this technology, they use some lasers with very, very low power. So there's absolutely no risk of explosion or ignition, fire, whatever, in hazardous area. And very important also is to say that we have ATEX and ESAX certifications for all our interrogators and sensors. Yes.
This is a key point also. We don't have on the market very.
No, there's only very few people.
Yeah, very few people able to offer this indeed.
Yes, and this is very important because it's mandatory by law to have the certifications in these kind of environments. And many people say it's only light, but if you have a very powerful laser that is injected into the sensors, then you have risks. And also, the second point is that it's not only a matter of light. You can have some materials like plastic, like aluminium, that require very specific, they are allowed, but with some specific restrictions and things to do, like having a cover or being very careful when washing, when cleaning it, not to have some sparkles. So we have all the documents for this. And okay, the last of these main benefits is the very low optical attenuation of the optical fibers. And so you can measure over very, very long distances. We speak of kilometers, of several kilometers, without repetitors, without problems with power supply. And this is extremely interesting in with our hazardous area, where the sensors can be inside hazardous area, inside where there is risk of explosion, and the interrogator can be
in a safe zone.
In a safe zone, a few kilometers away. We have an application for this in the south of France for LNG gas leakage detection for very big LNG tanks.
LNG tanks, yes.
And the interrogator is 2 kilometers away from the tank in a safe area, so it's much easier for maintenance, for anything we need to do with the system.
So it is important to point out all these benefits compared with conventional technologies, because after all, SCAIME is a manufacturer of sensors with electrical strain gauges. So we value very much the benefits of the FBG, and that is precisely the reason why we invested in this range some years ago, in order to have access to these markets where our conventional sensors would not be able to fulfill the requirements.
So then okay, very quickly, our standard range of sensors, then we can have some more specific, but mainly we measure deformation with different kind of strain gauge. Some that the first on the left is to be just bonded on a structure. Then we have some that can be welded on some mechanical structures. The third one is for I mean, for concrete or tar, the sensor is embedded directly inside the material, so inside the structure. So it's very robust, so that it can resist to this kind of environment. And then we have also long base strain gauge to measure about over 1 meter, 1.5 meter. Then we have some displacement sensors, some tilt meters, accelerometers, and temperature. Then we can also have on specific demands from pressure. We have already delivered pressure sensors or other kind of sensors, but it's more on a, how do you call it, sort of client based,
custom based,
yeah,
for specific projects indeed.
So don't hesitate to ask if you have specific measurement to do. Then our ranges of interrogators, so 3 range, MDX 100, 400, and 8000. The main difference is the frequency. The MDX 100 is for static or quasi-static measurements. Then MDX 400, 100 Hertz, and MDX 8000 for higher frequencies up to 2 kilohertz. This is the main point. Then in terms of optical channels, the 2 first have only up to 4 channels, whilst the MDX 8000 can have up to 8 channels.
Patrick will explain in detail how many sensors can be mounted on a line, but it's already interesting to see that to calculate how many points, how many measuring points you can have monitored by one interrogator in case of a 8-channel interrogator. That is quite huge. At least 80, but you will say more in detail how to determine the number per line.
Then, in terms of communication, they all have work with Ethernet communication, so they all have integrated web server that I will present after to set up the parameters. And the MDX 100 and 400 can also come with CANopen in option. And they also all have internal memory for direct data logging on the memory. I will also speak about that a little bit later. And last, they all also have digital input and output for alarms and triggering. I will explain also this. In terms of typical applications we have, to date, our main clients are working in offshore and marine applications. Offshore structure monitoring, for example, we have equipped a lot of ships like the French aircraft carrier Charles de Gaulle that has a lot of some monitoring system from SCAIME, and some frigates also. And for military ship, for example, it's very important to be, or not to be sensitive to EMI because, of course, of the radars, of the sonars. So if you use conventional strain gauges, then when you start the radars and the sonars, you don't have any signal. I mean,
there is a risk of disturbance of the
disturbance,
and you get nothing out of your monitoring system.
And there's nothing. Yes, of course. So we have equipped this, but also some icebreakers. We have also some
race boats. More recently, for
yes.
the race around the world, some of the race ships or flying boats, as we say, were equipped with MDX interrogator and SCAIME sensors. The idea is always the same for structures in a difficult environment like a sea environment, where the strains applied are extreme, like in those race boats. It's very important to have something that is able to predict a potential problem. Predictive maintenance is a key word in these applications.
Yes. And also the application is to have a better knowledge of the what is the structures, and it can be very helpful for new designs in the future to have a better idea to decrease the error margin or the. Then also other still in offshore in oil and gas, a lot of application in oil and gas on FPSO, also on offloading buoy for the mooring line monitoring, and basically also we can work in the drilling platforms, and I mean about everywhere. Yes.
Yeah.
Here we have the two advantages of very easy, I mean, ATEX certification, but that doesn't need some very expensive Zener barriers or junction boxes or this, because the sensor themselves are just simple, ordinary and standard sensors, and so the price is better. And we can combine this with the very good resistance in to seawater of our sensors and of the optical fiber. So these 2 points make it a very good solution for oil and gas applications. Then we also have application in marine energies. So I will start with the right, with the offshore wind turbines for both foundation monitoring, jackets or monopiles, and also for blade monitoring of the wind turbines. And also with wind turbines, we have substations, foundations monitoring,
and more consultation today for new projects in floating wind turbines, which is also demanding in terms of structure monitoring.
Exactly. And we have quite some applications in North Sea, different fields in the North Sea. And also here in the tidal turbine. So the turbine is inside the water about a depth of about 30 meters. And we have different monitoring of the structure, of sea pressure, of acceleration for the bearings, and it's a new market that is coming up. This was the first. It's between the prototype and the series. It's the pre-series, and they foresee quite big production in the future of this kind of I mean, energy power plant. Then this was more typical or more known for FBG technology, which is civil engineering. So we have worked for some historic monument like the Panthéon in Paris, but others. This is the Monaco Pier in Monaco, of course, where we have different sensors inside water or in dry area, or some tunnels, some bridges, and in tunnels we can have application very recent for several kilometers. I think it's about 20 kilometers long, with different sections to be monitored. And here the interrogator optical fiber is the low loss, and also in tunnels you can have water penetration. So these are the two key points that make the okay. And then railway. For track monitoring on the rails or the foundation under the rails, and this kind of applications, and for pantographs also. These are the main areas at the moment.
Very disturbed electrically.
Yes, because you have a lot of the power is passing through the pantograph itself, and so the sensors are bonded onto the copper part.
Yeah. So only fiber optic sensor can solve the problem here. Huh?
Yes. Or it would be very difficult to have very shielded cables that will have to go very far from this part. So it's not really possible. Now, the key question I mentioned, which is more specific to FBG technology when designing a monitoring installation. In our datasheet, we say that we can have a maximum of 16 sensors, but this is the maximum that the system can handle per line, of course. So if you have 8 lines, it's 16, 8, so it's 128, something like that, which is low. Then the point is that here you can see the spectra where we have 9 peaks, which represents 9 sensors. And you can see that sometimes the peaks are quite far from each other, and sometimes they can be very close. And if this first sensor, let's say it's a deformation sensor, and then you have extension, the peak will move to the right. And if in the same time the other one moves to the left, there can be a moment that they will overlap, and then we lose the measurement. So to make this, to avoid this, the idea is to, the first point is to, for each sensor, for each measurement point, to estimate which will be the maximum range. So I say for the sensor, but more for the application. For example, we have sensors that can measure from -5,000 to +5,000 microstrains. But if you take this range for all, then you will see that you will have very few sensors. If you are on metallic parts, usually it's some few hundred, 1,000 maximum. So if you know that you won't have more than 1,000 microstrains, then you say, okay, my sensor, my peak needs to be free for 1,000 microstrains. And you do that for each sensors, and then you will calculate for each one the wavelength range. You will just use the coefficient that transform the wavelengths into, for example, microstrains, and you'll just make the reverse to calculation very easily. And so you can, from this, you will have some kind of bands that tend to be reserved. There are a lot of bands here, but there are 9 sensors. And for each sensor, you will estimate the bands, which will be the maximum wavelengths and the minimum wavelengths. And like this, we can add sensors, and we can see here, there are some free spaces, but for sensors that will have only small space. And it's from this estimate that we can decide the real number of sensors. So it's not only from the tender data sheet, but it's really from the application. Mm-hmm. Of course, we don't always know all the exact value of the application, but at least we can have an idea of limited risk, of course. And then we will parameterize this in the web server. We will see after, and so if the peak goes out of this reserved band, then it will the sensor will be seen as a defect sensor, even if it's still alive. But just to avoid these overlaps, then it will be ignored, just to make sure that there is no problem. I hope that was clear. I will see if we have some. If you have any question, don't hesitate. Our Yvan will try to pass them to us later. So installation of the sensors, I won't make a training here, but just to say that we have different tools to help our customers. We have user manuals for the systems, the interrogators mainly, and for the sensors. We have also technical notes like this one. Don't try to read, it's not the idea. But the idea is just to say that we have these documents. They will just say how to handle the optical fiber. It's easy, but you have to respect just some radius of curvature, some few things that are different from electrical. So we explain that so you can be very cautious. We also give in this case, if it's for bonding, some glues that we have selected that we know that they work well. It's not mandatory to use those, but at least you have some ideas. surface preparation for the bonding, and then with pictures, the different step of the installation. So we have this is an example for viewing, but we have the same for welding sensors, for long base sensors. So we have them on the website, I think.
Yes.
Or at least we can,
yeah.
or otherwise we can provide them
This
very
is
easily.
a document that can be downloaded from the website, or in the worst of cases, we can send it to you if you don't manage to download it.
Yes, so this is the first point to have something, but then what we propose also is trainings. So it can be trainings at SCAIME here in our facility where we have some sensors, some everything to help you, or it can be also done in the client facility. And then, and also on site during the installation of the monitoring system or commissioning, where we can make training with some people going there and helping to have people very quickly, they can work very quickly.
Get familiar with the,
yes,
the technology indeed, yes.
We are not really an installation company. We don't have some teams traveling around before that, but we have few people here that can go and mainly make training and even help for installation, but not long basis, of course.
But this is something that we do on a regular basis for
Yes.
since we started to sell this technology, and we are used to support our customers and the users and the installers this way, and it works fine.
Yes. So now that we have designed the lines, we have checked installed all the sensors, and we are ready now to start the system I mean the interrogator to start to set up everything. So the first point, it's not shown here, but when you, well, no, the first point is that we use, you can see, I think it's Chrome or Mozilla web server web browser, sorry, to connect to the integrated web server. There is a very important point. There is no need of a specific homemade software to connect to the system. There's no risk of having the laptop that doesn't have the right software. You just need a very, very standard computer, and you just enter the IP address in the browser bar, and then you can access to the system. The first system is password protected with 2 levels of password, modification, so full access, and only visualization. So here you have the main parameters that can be modified, like the IP settings. We have some static relays to send alarm that can be programmed by the client with for system failure, for sensor threshold, sensor failure. There are many kind of way to have a very quick alarm on a digital output connector. And we also have some small diagnostic. I mean, the diagnostic is on the laser mainly, which is the critical component, of course. So we check the temperature, the power, the current, and all these parameters. And if there is a risk for the laser, it will be switched off automatically. It's not. It's only to prevent damages. So then, when temperature decreases or when everything comes back okay, it will restart automatically. It's just to make sure that if there is a problem with heat, that there is no risk of damaging the laser. You can also change the password, of course, and save all the settings on your computer or in your files. So if there is a problem and you have to change the unit, then you can upload the file, and then all the parameter will set back automatically without having to change everything. Now, once you have access, everything has been fixed on this point. The first step is to check the optical lines, and here this you have the spectrum. You already saw it before in another slide, but this is very convenient during installation. When you install the sensors, you can check first that you have all the sensors. Here I have 9 peaks. If I have installed 12 sensors, there is a problem somewhere. So you can go and check the sensors. And also sometimes it's only a big loss because a cable has been foiled or something like that. So you have, for example, the 5 first peaks are high like this, and the other are just on the blue line. And so you can go and check between the 2 sensors if there is a problem. And then when everything is finished, when you think everything is like this, quite okay, so you can consider that installation is okay. And also, what is important, you can save the spectrum, this graph on the computer. It's a text file format, so that can be opened by any software. And then every month, every year, or when you go to the installation, sometimes you can check the spectrum, save it, and you can see the evolution of the installation in time. Just comparing this, maybe one peak is decreasing, so or going something. So this is very important for installation. And here you can adjust the gain of the peaks. I mean of the detection. So if you have too low signal, you can adjust the gain, and you can adjust the threshold for detection. So once the spectrum looks okay like this, we can go to the sensor setup. So it quite a lot of things, but you will see it's very easy. The first point is that we have a button here, auto detect sensors. If you see it, and this, if you press this, it will check all the lines with all the peaks on all the line, and it will pre-fill up this table here with all the sensors line by line. So then you just have to enter the parameters. You don't have to enter all sensors one by one, add sensor, new sensors, or it will be done automatically with the reference wavelengths will be entered. And then for these parameters here, to fill it up, it's very easy. We provide with our sensors. Here you have on the left, you have a picture of a typical sensor datasheet, which is delivered with the sensors. And I know it's difficult to read, but believe me, you have the parameter A, which is A, B, which is B, C, D, etc. All the parameters. So you just have to enter the figures inside the relevant box. Then just here I spoke about the yellow line. If you remember the ranges, the maximum expected ranges, you can enter them here for the minimum and the maximum, and it's not in wavelengths, it's in physical value. So microstrain, temperature, acceleration, and then the system will handle to transform it and to make the band to check if the sensor is okay. And the last, the four on the left, right, top right, sorry, are test box. So we have said, so this is a name, the sensor reference, a number, or also measurement unit. But you can use it at your convenience. It's not used for any measure, any calculation, and it's just so it can be used for other applications, purposes, yes. And also, so you can see that the calculation is the order 3 polynomial. for the calculation. Here we only use linear, but we can have V2 up to third order, and for temperature compensation up to second order. And yes, of course, we can also make when the installation is finished, we can make the 0 for especially for the strain sensor, to say, because we know when bonding, there can be some small stress. So when everything is finished, we just press the 0 and the 0 here, and it will make the 0 of all the sensors. And last, you can download all these parameters on your computer. So if you have one, okay, if you have a problem, then you have all your parameters in safe place. But also, if you have several installations, it's more the case in civil engineering. Then you have all your, I don't know, bridge number 1, tunnel number 2, etc. And you have all the files in your computer. And when you go to the place, you can upload directly all the sensors parameters without having to do the job again. Ah, yes, I forgot the last point is the thresholds for the sensors. You can define thresholds. So you have different modes like in-band, out-band, higher, lower, one very classical, that's mini with a low level threshold and high level threshold. So this, we will see, it's mainly used for data saving. You will see that later. So then we have another tab which is only visualization. Once you have made all the setup of all the sensors, you can check the signals to see if the behavior of the signal is what is expected. For example, for a blade, if you have a sinus, or for when you know what you expect. And here you can see the threshold. This is outband. If you are in the band, it's wrong, etc. And different examples. Also, another important point in this, you can have the visualization also in wavelengths, in raw wavelengths without any treatment. So if you have some specific sensors that are not from us or that you want to calibrate, then you can use the wavelength value. And from this, you can make the calibration of the sensor and then enter the parameters into the system.
Okay.
And time synchronization and data logging. The module for data logging is we have different way to log the data. It can be what we call user control. So you just have start recording, stop recording in continuous mode. But you have also a lot of other modes like a periodic data logging. I don't know, 1 hour per day or things like that. And also you have possibility to trigger, yes, the data logging on events. For example, if the temperature is passing 20 degrees or 30 degrees, then you start logging the data. And then with the possibility to store the data just before the trigger, and a different mode to say when you want to stop logging the data, if it's when it's going back down, or if it's on defined time, etc. And in this, time synchronization or date settings module, we have four possibilities for timing. Just internal clock, and it will work, the most standard. Then we can also have a synchronization with a NTP server, a network time protocol server, so on the Ethernet. We can also have a GPS antenna. All our systems have an input for a GPS antenna, and then we will synchronize the internal clock to the GPS antenna, GPS time, sorry. And last is the external trigger. So we have a digital input And on each TTL pulse, it will make a measurement of all sensors. All sensors are measured exactly at the same time. So this is useful if you have different modules. Then only one PC can just synchronize the data acquisition of all the modules. And when you have saved all the data, if you use, of course, the internal memory, to access the files, you have a FTP server inside also embedded in the interrogators, and you just connect to the interrogators. So where is it? On the left side, it's the computer, and on the right side is the index memory. And we have some text files. The logs are text files, and you have an example down on the right of the text files with the first timestamp with date and time, and then the sensors values, and also all the MDX parameters in the first row. So you know exactly what was the temperature, what are all the parameters of the MDX, and you have all the data of the sensors. And I think we are.
I assume that we saw on one of the slides that the capacity of the memory is 32
gigabytes. Yes.
Gigabytes. When of course it takes a long time until you fill this memory. But what happens if you have reached the maximum capacity?
It will stop recording.
So you have to clean
yes,
and reset. Okay.
It can be quickie if you have a 2 kilohertz with 100 sensors.
Yes,
we don't recommend using internal memory.
Thank you very much, Patrick. It is very important to stress, to highlight the advantages of the fiber optic sensor range, which is clearly a strategic objective of the priority of the SCAIME development in the years to come. And so we see already the benefits in terms of new business, and we discover new possibilities every year. So it's very important. So I turn to my colleague Yvan, who is the supervisor of this session, technical supervisor. Do we have some questions from the audience?
Yes, here are a few questions asked by the viewers during the presentation.
Okay. So, one question there is about defective sensors in optical line. If there is one of the sensors is detected defective, does it affect the measurement on the whole line from the other sensors, let's say?
Well, if a sensor, since the sensors are in series on one optical fiber, if the sensor is broken, because you can maybe have some defect, but the sensor is not broken, but if it's broken, then of course you lose all the rest of the line. The light will not be transferred. So not to prevent this, but just to, in case this happens, what we usually recommend for application is to have a loop back from the last sensor to the interrogator. So optical fiber that is coming back to the interrogator, it's not plugged, it's not used if there is no problem. But then in case of problem, we can have access to the sensor through the other side. So we lose only, then we can interrogate all sensors except the one that is broken.
Okay, so it's a trick to...
So yes, because we cannot avoid, I mean, there can be some problems, but the other point on this is that if one sensor is having problem, there is no influence on the other sensors in terms of measurement, stability or whatever. There will not be disturbance like crosstalks or things like that.
Okay, good. We have another question about wireless transmission. So can we implement wireless transmission from the interrogator?
Yes, we can implement. It is not inside the interrogator itself, at least at the moment. But we made the choice to use Ethernet TCP/IP link, which is very standard. So any routers that can be found anywhere, with Wi-Fi, with Bluetooth, with 4G, soon 5G, can be used connecting the Ethernet link to the router.
Okay.
So it's not inside the box, but since we use very standard protocols, then we can easily find a lot of choice on the market for this kind of product.
Well, that's all for the questions. Of course, if you think back of another question, you still have some ways to set contact with us through the website, for instance, or if you have our direct addresses, Patrick and I, you can send mails whenever you want. We thank you very much for your attention, and hope you found this presentation instructive. And well, from Patrick and I, we say goodbye.
Yes,
and
bye-bye.
Maybe to another session in the close future. Bye-bye now.